All right, guys, one remaining problem on Markov chains, then it'll be uh, time for your assignment. So hopefully you've watched all these. This one's a little more difficult, not a lot. It's the same principles. Just we'll see that we have. I wanted to give you a situation where we had uh, a a problem with more than two states, just to show you what it creates. Okay, so I came up with this problem somewhere. So to keep track of its location, the location of its cabs, Zephyr Cab has divided a town into three zones: Zone 1, Zone 2, Zone 3. Records show that of the passengers picked up in Zone 1, that 60% are discharged in Zone 1, 30% in Zone 2, and 10% in Zone 3. And if you go ahead and read the problem, it tells you the percentage that are picked up in Zone 2, that are discharged in Zone 1, Zone 2, Zone 3, and those picked up in Zone 3 that are in Zone 1, Zone 2, and Zone 3. And then we have an initial state, we have some initial um, information, and we want to answer these questions. So this should be pretty quick. This is the only handout that I'm going to work in this particular problem. So the very first thing that I would want to do is I would want to identify the states here. So I'm going to let state A, let's call, so this is picked up in Zone 1. A prime is picked up in Zone 2. And a double prime will be picked up in Zone 3. All right, so I actually used Roman numerals up here for some reason. So Zone 1, Zone 2, Zone 3. All right, so we can look at, even though it doesn't ask us to look at the transition diagram, we can do that. So we can do A and A prime and A double prime. This is going to get a little bit messy, but so we could start out in A prime and stay there. We could start out in A double prime and stay there. And we could start out in A and stay there. Or we could go from A to A prime, or A to A double prime, A prime to each of those. This is going to get really messy, isn't it? But we are smart people and we will figure it out. All right. So starting in Zone 1 and being picked up in Zone 1 is 0.60. Moving to Zone 2 is 0.30. And moving to Zone 3 is 0.10. So notice that everything coming out of, ooh, I got that wrong. So everything coming out of A, 0.3, 0.1, 0.6 adds up to 1. Now, for those picked up in Zone 2, 40% are in Zone 1. So I'm going to circle that. 30% stay in Zone 2, and 30% go to Zone 3. And those picked up in Zone 3, we have 40% who are discharged in Zone 3. So I'll put that there. 30% move to Zone 1, which will be right here. Isn't this fun? All these lines. All right. So the transition matrix is going to be a little bit cleaner in this case. In fact, it's going to be a lot cleaner in this case. In that we can look at All right. So let's put this information the way that we need it. So 60, 30, 10. Uh, 40, 30, 30. And 30, 30, 40. All right. So find the transition matrix. So we have that. So what is the distribution of the cabs after all of them have made one pickup and one discharge? So guys, we know that A0 has to be what happens at the beginning of the day. So we have 0.80, 0.15, and 0.05. Now, let me explain something very important here, because I've seen different books change the order here. Now, if I am wanting to calculate A1, then I'm going to take A0 times P, which A0 in this case is a 1 by 3, and our P is a 3 by 3. Now notice that P times A0 doesn't work, because it would have a 3 by 3 and a 1 by 3, and it doesn't work. So what a lot of books that I've seen, at least I've seen this presented in a lot of textbooks, is if it puts the P matrix first, probably helps if you get this up where you can see it. If it puts the P matrix first, which it could, then this initial state vector, or this initial state matrix, which is a row vector here, would have to be a column vector. So guys, if P went first, then A0 would have to be now. I don't know if my math lab is going to, or the online course management system that I use, excuse me, will present problems differently. But if they do, if the probability matrix comes first, then the initial state matrix has to be a column matrix, and not a, well, I should say column vector, and not a row vector like the examples that I'm using. But nevertheless, guys, we'll still use our calculator here to make these calculations. So we're working problem B here. So what is the distribution of the cabs after all of them have made one pickup and one discharge? So they made the pickup at the start of the day, and then they're going to, actually they're going to make the pickup and then they're going to discharge from there. So essentially, guys, what we need to be able to do is find A1, which should be pretty daggone easy, right? If I can get the lighting right where you guys can see this. So guys, my matrix needs to be a 1 by 3, the initial state matrix, and this needs to be 0.8, 0.15, and 0.05. So it adds up to 1, which is cool. And then my other matrix needs to be a 3 by 3. So we need to carefully type these values. And now it's as easy as just multiplying A times B, which I can use this form from a previous problem, and get a dim mismatch, which is just perfect. Now, why is it doing that? Did I overwrite that? Huh. Yeah, sure did, guys. Pulled a boo-boo there. So let me go in, and I'm just going to go down and change this one to the 1x3. So I'll let this be my initial state. Well, got sloppy there, didn't I? But it happens to all of us. All right, so gang, instead of taking A times B, I'm going to have to take B times A. And we see that we get A1 is equal to 0.555, 0.3, and 0.145. So the question, what's the distribution of the cabs after all of them have made one pickup and one discharge? Well, 55% are in zone 1, 30% are in zone 2, and 14.5% of them are in zone 3. Now, problem C, what is the distribution of the cabs after all of them have made 2 pickups and discharges? Well, guys, that just tells us that we need to find A2, which can be found by taking A1 times P. Well, gang, I've got A1 right here, so I can just store it as, now guys, remember, that's actually B now, because I screwed up the order. Didn't aim to, but I did. And now I can go up 2 levels and get B times A and find out that it's 0.4965, 0.300, and 0.2035. Yeah. So guys, this would be the answer to part C. Guys, it's that easy. Keeping it light on Markov chains. I just want you to be aware that these things exist. Have a little bit of experience. This is an applied course, so we're not going to get too theoretical. I just want to keep it simple and let you know. If you get stopped on the street and someone says, "Hey, I know you completed Darbro's Mass 1700. What's a Markov chain?" At least you'll have a clue. At least you'll have a possibility of getting that answer correctly. So, guys, have a good one.